First thing I need you to do is I need you to go here, down here in this position and make sure there is a negative here in front of the square root of 3. This represents the tangent at this angle. We have a -1 tangent at 315, and this should be a negative radical 3 over 3. So you are adding these two negatives in. We're going to come up top. We're making sure we see the negatives there. That's perfect. Everything else is good to go. The information on this sheet is information from Units 11 that we will have to have memorized. It's information from Unit 12 and going on to Unit 13. Okay, so all this information will be valuable for us. Okay, are you ready? So let's get started. Very first thing I need you to write down, please no additional talking as I am going through and filming this for students who are in periods 1, 2, and 4. Please write down example number 1 in your notes. Now, if you are unaware, you don't get to bring a unit circle into the AP exam, so you have to have a basic understanding of what this is. So the idea of trying to memorize all of this different information for every single angle seems overwhelming. So what I want us to be able to do is, I want us just to know this very first quadrant. And so if you could do me a favor, we will refer back to it, but if you could do me a favor and let's just draw quadrant number 1. And we are just going to look at those common points of 30 degrees, 45, and 60. So what is the quick way as a reminder that I go through and do this? This is 1, 2, 3, 1, 2, 3. I'm placing a 2 on the bottom of everything. That may not show up very nicely for people in back. Let me go over the top of this with a darker color. So 2 goes on the bottom of everything. And now when we look at the numerators, if we can take the square root, and it equates to a nice integer, we'll do that. For instance, I know the square root of 1 is 1. The square root of 3 is irrational. The square root of 2, irrational. The square root of 3 is irrational. Now I have the ordered pairs for the 30, 45, and 60. Remember, it's cosine before sine. Let's do one more thing. Now we could identify the tangent for each of these. The tangent of this spot is really easy. It's 1. When you take the sine and divide by the cosine and they're the exact same values, we get a positive 1. But we could do the same thing here. We could take sine divided by cosine, but we're going to cheat here. We're going to come back to this paper that you picked up, and we're going to do, this is radical 3, so this is our tangent, and this is radical 3 over 3. So I'm going to circle these just so they are separated. So now we have the cosine, sine, and tangent of these common points. And we can use that when we identify the other points on the unit circle related to 30, 45, and 60 degree reference angles. Let's get started with example number 1. Okay, very simple algebra. I'm going to add the square root of 3 to both sides. I have 2 cosine of x equals the square root of 3. Then I'm going to divide by 2. And I have the cosine of x equals positive square root of 3 over 2. Now what I want you to recognize is what number is in front of the x? A 1. It's a hidden 1. So we're only going to do one revolution here. So in one revolution, where do we find the cosine to equal positive radical 3 over 2? Well, let's also go off to the side and write all-star trig class. Okay, so I know cosines are going to be positive in these two quadrants. So here we go. Cosine is positive right here at this angle. So what is this angle? This angle is 1 pi over 6. But I also need a reference angle of pi over 6, also known as 30 degrees. I need that in quadrant number 4. So if I drop down 30 degrees, what would it be? So let's come back over here. So if I drop down 30 degrees, this is where it is. If I drop down 30 degrees, this is where it is, also known as 11 pi over 6. I'm going to press pause. So if you are watching this video, students are now working in groups of 2 to go through and to solve a very similar problem. we will have different answers. And I'm asking them not to refer to the unit circle on the provided reference sheet. So how would you go about doing this? In one cycle, I want to know where do we find negative radical 3 over 2. So cosine of negative radical 3 over 2. So, okay, it's going to have a reference angle of 30 degrees, but it needs to be negative. So reference angle of 30 degrees or 1 pi over 6, but it has to be a negative cosine, which is in quadrants 2 and 3. In quadrants 2 and 3, that would be right here and right here. So I'm simply going to count 1, 2, 3, 4, 5. Okay, one answer is 5 pi over 6, 6, 7. The other is 7 pi over 6. Both of these angles have a cosine value of negative radical 3 over 2, and we can see that right here, negative radical 3 over 2 and negative radical 3 over 2. This is officially the second example, and so the only difference is we're not looking at one of the primary trig functions, we're looking at a secondary trig function. So we are going to get in the habit of showing all of our work, even though I know a lot of you would just subtract 6, knowing that your AP exam requires a time commitment, and so you're going to be rushed. If you're not used to showing all of your steps, we don't want to lose any points. Okay, all of this looks wonderful right now, but I want to rewrite this. So remember that I can rewrite the cosecant as 1 over the sine. So if I rewrite this as one of the primary trig functions, bless you. And if you're wondering why would I write it as one of the primary trig functions, well, if we go back here to this page where we did just some rough drawing here, notice that each one of these are primary trig functions, sine, cosine, tangent. So I want to rewrite this. I know that the sine of this is going to be the reciprocal of this outcome, which is negative 1/2. All right, where can I find the signs? First of all star trig class, where are the signs negative? The signs are negative in quadrants 3 and 4. So I'm looking in quadrant 3 and 4, and I want to identify where can I find a sign equal to negative 1/2. Let's go back to this part. Sine, okay, so a sine is at 1/2 when it's at a 30 degree or a pi over 6 reference angle. So I'm going to come here. This is where the positive 1/2 is, but I want negative. So I'm going to drop down 30 over here and drop down 30 over here. These are my two answers. How do I find those? By counting 1 over 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. Okay, this is 7 over 6. X equals 7 pi over 6, 8, 6, 9, 6, 10, 6, 11, 6. Why did I do 1 full revolution? Because the number in front of the X is a 1. Later on, we'll see where it is a 2 and possibly a 4. Let's write down example number 3. What is different about example number 3 versus example 1 and 2? The difference is, please put an arrow here above. So the difference is we do have a square. Now let's go off to the side and let's talk about 8th and 9th grade math. And you don't have to write down what I'm putting down. If I put down x squared equals 4, you would take the square root of both sides and you'd go, okay, I need to have two answers, plus or minus 2. We're going to do the same concept over here. So first, doing PEMDAS backwards, I'm going to do adding or subtracting first if it exists. Then let's get rid of multiplying or dividing second. And now I have cosine squared x equals, well, hold on here. When I set up this problem, I meant to do one thing. I meant to do something else. Do me a favor right now. I need you to make this right now. Hold on. This will still work. This will still work. This is a 1/2. Does everybody agree upon that? Okay. I am now going to take the square root of both sides. So I have the cosine of x equals plus or minus the square root of 1 over the square root of 2. The square root of 1 is 1. The square root of 2 is irrational. Nothing that I've done is wrong, but we don't want to leave our final answers with a radical in the bottom. So I'm going to do the square root of 2 times the square root of 2. As long as these two values, bless you, are in the numerator and the denominator, we've simply really multiplied by 1 and haven't changed the value of this original fraction. Now I have 1 times the square root of 2 is on top. On the bottom, I have the square root of 4, and we know the square root of 4 is simply 2. So this is what I have for my answer. So now I need to ask myself, where do we find the square root of 2 over 2? Now, I'm trying, if you came to class late or if you were rewatching this, I'm trying not to refer back to this because this will not be on our AP exam. But we can write this very quickly on our AP exam. So, where do I find cosine, knowing that cosine is our first value as an ordered pair? Where can I find that? Okay, square root of 2 over 2 for the cosine is at our 40-degree increments. Bless you. So that means right here is the square root of 2 over 2. Now, I want both positives and negative. That's in these places right here. Cosine, like our x values, are positive on the right in quadrants 1 and 4, and negative on the left in 2 and 3. So how do I write these down? And we're going to see these in terms of radian measurements. So this is where students often get confused. We're counting now with 4s on the bottom. So this is 1 pi over 4. 1 pi over 4, or just you can say pi over 4. 2 over 4, this is 3 over 4. 3 pi over 4. 4 over 4, this is 5 pi over 4. 6 pi over 4, and 7 pi over 4. These would be the answers in one revolution. Why did I do one revolution? Because there's a 1 in front of it. So here's our next example, example number 4. I'm adding 20 to the opposite side, and as I'm doing this, I'm recognizing two things. One is I have a secondary trig function, and 2, it is squared. Dividing by 5, dividing by 5. Secant squared x equals 4, and then I need to take the square root of it. Remember, I'm going to have two answers, plus or minus 2. Now, we talked a lot in Unit 11 that the secant of a value is the same as 1 over the cosine. So the relationship is these are reciprocal. So I can write this as the cosine of x is equal to plus or minus the reciprocal, which is 1/2. Cosine is our first value. Let's go up here. Cosine, the first value, is in this position, which is known as 2 pi over 6, pi over 3, however you want to reduce it there, or 60 degrees. And notice we have plus or minus. So I'm going to come here really quickly. I'd like you to do the same and do a 60-degree mark. And we're going to do 60-degree reference angles in each of the quadrants. The first time I write these down, I'm not going to reduce them unless you've already memorized what they are. If you've memorized what they are reduced, awesome, go ahead and do that. But to help other kids, I'm not going to reduce them initially. So I have 1 over 6. Okay, this is 2 over 6. 2 pi over 6. 3, 6, 4, 6. So this is 4 pi over 6. 5, 6, 6, 6, 7, 6, 8 pi over 6. 9 over 6, 10 over 6. 10 pi over 6. Then I'm going to go back and reduce. So 1 pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. I did one revolution, and these are the 4 places where we end up with a plus or a minus for the cosine. So a couple different things as I'm filming here. Notice this means we're going to do 2 revolutions, and we also are going to have a plus or a minus here. So if you want to think of this right now as just sine squared x equals 3 with the 4 in front, that works as well to start with. So I already have 3 on the opposite side. I'm going to divide by 4. I have sine squared x equals 3/4. I'm going to take the square root. Remember, that has to be applied to the numerator and the denominator, and we will have 2 answers. So square root of 3 over the square root of 4. Let me rewrite that. The sine of x equals the square root of 3, and I know the square root of 4 is 2. Don't forget about the plus and the minus. Okay, so where is sine? That's the second number in the ordered pair. Where is it equivalent to radical 3 over 2? Sine is the second number. Okay, that's right up here at 60 degrees. So I'm going to draw my picture. This is what I would suggest you do, and go up to 60. Because we have plus and minus, I want you to do a 60-degree reference angle. And if that's like, okay, I recognize those words, but I don't know what that means from this horizontal axis, we're going to push up 60, and we're going to push down 60, push down 60. So those are my reference angles. Now, before I start counting, this 2 in front means we're going to do 2 revolutions. There's a couple different ways you can do that quickly. I'm going to do it the slow way, though, so that everybody understands. Okay, so counting right now by 30-degree increments. So 1 over 6, 2 over 6. So 2 pi over 6, 3, 6, 4, 6. 4 pi over 6, 5, 6, 6, 6, 7, 6, 8, 6. 8 pi over 6, 9 over 6, 10 over 6, 10 pi over 6, 11 over 6, 12 over 6. I'm going to keep going. We have to do another revolution. So here's 12 pi over 6, 13, 14, 14 pi over 6, 15, 16, 16 pi over 6, 17, 18, 19, 20, 20 pi over 6, 21, 22, 22 pi over 6. So I should have 1, 2, 3, 4. I should have 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to quickly reduce these. So I can reduce to get final answers of 1 pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Okay, 14 and 6 reduce to 7 pi over 3, reduces to 8 pi over 3, reduces to 10 pi over 3, and lastly 11 pi over 3. Those are my 8 different values going around the unit circle, 2 revolutions that produce a sign value of positive or negative radical 3 over 2. This problem, I want you to take just a second and I want us to consider, let's go back to a concept from freshman year. If I said x times y equals zeros, we have a couple different scenarios that could occur. Either x is 0 and y is any other number. So like for an example, 0 times 2 is 0. Do we agree with that statement? So either x is 0, could be the case, or maybe y is 0. So x could be any number. So it could be like 3 times 0 equals 0. Oh, that's true. So either x is 0, y is 0, or they both are 0. That same type of concept will apply here. Either this is 0, this is 0, or they both are 0. So we are now going to figure out what happens when we set each one of these quantities equal to 0. Do me a favor and draw an arrow above the 3. What does it mean? We need to do 3 revolutions. Okay, where is the tangent 0? A lot of students get confused between 0 and undefined. Okay, so let's do this really quickly. This is going to be 1, 0, negative 1, 0. This is 0, 1, and this is 0, negative 1. Define the tangent. We are taking the sine and dividing it by the cosine, but the cosine is in the denominator, and the cosine can never be 0. So of these 4 different positions, which ones have cosine of 0? The top and the bottom. So at 90 degrees and 270, it would be undefined. I can't use those two. These are the positions where when I take the sine and divide it by the cosine, 0 divided by 1 is 0, 0 divided by negative 1 is 0. Okay, so you ready? I need to start right here, and I'm going to go around until I'm able to come up with my position. So right here, my first value is 0 pi. This is 1 pi. This is 2 pi. This is 3 pi. We go back. Does everybody understand what I'm doing right now? We have 4 pi, 5 pi. Okay, so we start here, and we got 1, 2, 3, 4, 5, and 6. Maybe we don't need to count 0 pi. Maybe it's just like that. Because we're starting here, and we don't actually go until we lift off. So 1, 2, 3, 4, 5, 6. 3 revolutions. But here's the part people forget. What do I have to do next? Anybody remember? We have to divide. Nice job. We need to take each one of these and divide by this value here. So I'm going to divide by 3. So this cannot be reduced. So I have pi over 3, 2 pi over 3. Now 3 over 3 reduces to 1 pi. 4 pi over 3, 5 pi over 3, and 6 pi over 3 reduces to 2 pi. Now let's do the same type of concept. And by the way, how many revolutions do I have to do for this one? Just 1. Okay, so now we're going to do tangent squared x minus 3 equals 0. Plus 3 plus 3. So tangent squared x equals 3. Let's take the square root, knowing that we're going to have 2 answers because the plus or minus. And now, even myself, I would have to go back and think about this. Where is the tangent equal to the square root of 3? So I'm going to bring this down here. It's at 60 degrees that we have a tangent of the square root of 3. We have plus or minus, so that can be in any one of these positions. So I'm going to count here by 30 degrees. 1 over 6, 2 over 6. So 2 pi over 6, 3, 6, 4, 6. 4 pi over 6, 5, 6, 6, 6, 7, 6, 8, 6. 8 pi over 6, 9, 6, 10, 6. 10 pi over 6. You can see that if you never had a great grasp of the unit circle, how important it is right now. So if you haven't learned the basics of the unit circle, now is the time to do that. But here's the key. You ready? When I reduce these, I'm going to look back up here. And if any of them were repeated, I don't need to add to it. Like, for instance, this reduces to 1 pi over 3, right? Does everybody see how 1 pi over 3 is already there? Okay, I don't need to add it. This reduces to 2 pi over 3. It's already there. This reduces to 4 pi over 3. It's already here. This reduces to 5 pi over 3. It's already there. This would be my final answer for this trig equation.